see, when you consider energy, because electric motor has an efficient 90%. Whether
It's
you
only
are
vehicle, only
charging,
at the
yeah,
at
please.
the vehicle level. At the vehicle level, what we are saying is right, sir.
Uh,
But when we take from well to wheel, what I mean to
yeah,
say is, like from the very initial phase of like crude oil, which is being manufactured and then
yes, yeah,
produced, and then suppose it is being poured in the EV and all those things. And
yeah.
similarly for the EV also, like if we take the efficiency from well to wheel,
Mm,
then in the current scenario of energy that we have in India, where
okay.
still the coal, I would say, based energy is the prominent source of power generation, like facilities that we have. So in
Yes.
that scenario, whether IC is much behind an EV, or maybe it's equivalent, or it is better by some percentage. What is your opinion about that, sir?
Yeah, that's a very good question. We have two things. One is the battery technology, correct? The energy density of the battery. We are going to talk about batteries, different type of battery energy, how it is produced, or working, what is advantage, what is limitations, all those things. The battery was initially using lead acid battery. It weight to energy ratio, correct? Was very power, correct? So battery. If you take a battery, I already many times told you, if it weighs 10 kg, only 1 or 2 kg of the battery material, electrodes and electrolytes, is converted into chemical energy into electrical energy, remaining a dead weight. Okay, but in case of, if you talk about IC engine, if I have 1 kg of petrol, 1 kg of diesel, entire petrol is burned. Correct. So in that case, we will see that energy density, all those things considered, still the IC engine is better. But as a vehicle, we are talking. As a vehicle, if you have electric motor and the energy source is the battery. Battery, if you use the lead acid battery, it's not good. Now we have come with a lithium-ion battery, which is at least 2 times better than, comparatively, it is much time better. Now we are trying to develop much more higher energy density batteries. So if you try to compare like that, IC engine is still better, correct? The amount of fuel burned is fully converted into, so say 1 kg of petrol is going to so many kilojoules of heat, that is converted to mechanical, all this thing. But whatever you do, what we are saying, IC engine conversion is very bad. As such, today we'll see. Actually, if you see the current scenario, the main problem is with battery technology, one thing, and availability of battery, of time required for charging battery, availability of charging stations. That is one of the impediment for the electric vehicle. Otherwise, electric vehicle will quickly replace IC engines very soon. If better battery technology comes, and till then, nothing can go. That is as intermediate step, we are going hybrid electric vehicle. Engines are well proven, reliable, fuel is available by any nook and corner. Even go to Ladakh, you have the fuel station, petrol station, correct? Charging, say, all those things are not there. That is one reason. And when you talk about well to wheel, we'll see that extracting the crude from the deep, 2 meter, 2 kilometer, 3 kilometer depth, or from the, for example, Bombay heights of ocean, correct? Then bringing it to the cracking columns, petrochemical industry. There you have to heat the crude and cool it. There are so many processes, so much energy, all those things. Still, they say that the petrol production is cheaper than this one. For example, producing electricity using non-conventional sources. But slowly it is gaining. Now the solar cells, correct? Charging station, which converts the sun energy into this one. And the efficiency of solar cells are very bad, 10%, 12% from 10 years before. Now they have come to 22% something there. Israel, many countries are developing new solar cells, which has very high energy. So they say if solar cell conversion efficiency become 25 to 30%, automatically the IC engine will be removed from this one, because cheaper and continuously available, easily available, so sunlight. So then you can charge your battery. Two things: one is battery technology, other one is the availability of electrical energy continuously. Again, if you talk about solar energy, night time, no. 12 hours, absolutely no solar energy. Wind energy, we don't know when wind will go, when will stop. You know that in India also, For example, Gujarat is leading. Next is the Tamil Nadu, Tuticorin, correct? Western Ghats near that. Heavy wind is there. Some 3 to 4 months. Too much wind also. You can produce so much. But where you store the energy? Energy produced by wind energy. Heavy winds are coming also only in some regions of the country. It is not available throughout the country. That is another problem. And the 3 4 months suddenly there is no wind at all. So these are the problems with unconventional energy or green energy sources. Solar, wind, wave energy also. Wave energy also people tried, then they abandoned. Near Cochin, Villignam, one place. IIT Madras involved. There's a ocean engineering department. I am here in IIT for last 40 years, more than ocean engineering set up this one long before. I'm talking 25, 30 years before. But still that is not viable, not compared to burning coal. As you told that, cheapest energy production burning coal, because some amount of coal is available in India, or we can import from Australia somewhere also. It is still cheaper compared to anything else. That is another thing. Okay. So then we talk
so much,
about,
sir. Thank you so much.
yeah, no issue. Thank you. Okay. Overall efficiency hybrid electrical depends on. Okay, I said compared to IC engine, hybrid electric vehicle is better. Compared to hybrid electric vehicles are better. But electric vehicle has a lot of difficulty. We are in the infant stage, correct? But slowly it will grow. But hybrid electric has matured some extent, 30 to 40 years. It is there. It has somewhat matured, but highly matured IC engine. But we know the limitation. So again, even if you go to hybrid electrical as intermediate stage before going to electric vehicle, the overall efficiency of hybrid vehicle depends upon the relative size IC engine and the electric motors. I already told you, correct? I say that I have 100 kilowatt electric vehicle. What the total this one power, and say whether 60 kilowatt is the electric motor and 40 kilowatt is the ICE. Or what is the combination size, relative size of whether you are using bigger engine with smaller motor, or smaller bigger electric motor, smaller engine. We saw that. That also going to decide whether what is the efficient hybrid electric vehicle. That varies. IC engine based vehicle cannot recover. Another problem with IC engine is, as I told you, that you cannot recover the kinetic energy. Sorry. Braking, correct? The automatic spell correction, sometimes word this one PPT test, they call braking. Power wasted during the braking, correct? In conventional engine, as I told previously yesterday also, if you apply a brake, the brake shoes goes and physically touches the brake drum that is attached to wheel. That means the kinetic energy of wheel or vehicle kinetic energy is converted heat due to frictional forces, that is dissipated. That means energy is wasted, one thing, waste of energy, and the other thing is brake shoes are getting worn out, brake drum is getting worn out, then maintenance, all these things. Net result is lot of losses, correct? Economically, and also energy is wasted. So you cannot do. But if you go to hybrid electric vehicle or IC engine, the motor which is driving the wheels can be made as a generator, and we can recover the energy in the wheels, kinetic energy in the vehicle body which is moving, can be electrical stored in this one. So it acts, the generator acts as a battery. Sorry, brake. The generator works as a brake, and so it recovers the kinetic energy, converts, which can be used for again driving. So they say that by recovering 5 to 10% is possible. That's a peak possible is, they say 5%, 3%, 8%. Research is going on. Regenerative braking, how much you can recover. Right now, it is a 3 to 5% easily, they say, correct? If you properly designed. So compared to, so this is another advantage of hybrid vehicle compared to electric IC engine base. Okay. Then battery of EV helps in storing energy recovered from braking, called as regenerative brake, already told, by coordinate operation of optimal in terms of IC engines or electric motor, which should be run depending upon the driving condition, whether low speed, high speed, correct, you want acceleration, all those things. And the engine or electric motor, both will be work together or independently, so that the energy can be saved, less emission, everything is possible. This is the hybrid vehicle advantage, which already, apart from what we highlighted yesterday. This is what I already told you. And again, as additional points, please take the points. Okay, before we go deep into the hybrid vehicle design and other things, modeling, all those things, I just wanted to talk another set of configuration vehicle is there, and hybrid vehicle, what I call fuel cell based vehicles. Correct. We will see about fuel cells when we talk about battery technology. Correct. Battery technology, fuel cells, we are going to talk as separate, some 4 to 5 years. That time we'll talk more. But just one introduction lecture, I just want to show that fuel cell, fuel cell in electric vehicle, correct, or in hybrid electric vehicle, if you replace the electrical source, correct, the electrical power needed for driving the electric motor in an electric vehicle, if it is replaced by a fuel cell instead of battery, that means generally if you talk of electric vehicle, we are talking pure electric vehicle. I have battery, it can be lithium-ion battery for nowadays, and the power is taken to converter, inverter, from there it goes to the motor, and motor drives the wheel. And if the battery is replaced by a fuel cell, correct, and another device which produces electricity in a different way than how the electricity produced in the battery, then it is called as a FCV, fuel cell based vehicle. Similarly, this is a pure electric. Even in hybrid vehicle, because we know that there's an electric motor. Electric motor needs a battery energy source, electrical energy source. Generally, we use a battery, correct? Same lithium-ion battery, something. That is replaced by fuel cell. Again, this vehicle also will be called fuel cell based vehicle. Because somebody may ask, so which one will you call as this one? It is not necessarily only electric vehicle which is driven by fuel cell called as a FCV. Even hybrid electric vehicle whose electric motor is driven by electrical energy generated by the fuel cell, then the vehicle also will still categorized as a fuel cell based vehicle. That's what they say. You know that still there's a IC engine, but motor alone is driven by electricity produced by the fuel cell. Okay, what is a fuel cell? Fuel cell is a electrochemical cell similar to battery. Correct? There's slight difference. We are going to talk about again here itself. They showed that converts the chemical energy of the fuel. The fuel is often hydrogen. Fuel cell uses hydrogen as a fuel. Okay, so then by oxidizing agent, which is generally oxygen available. Fuel cell require two things. One is a fuel, other one is an oxidizer. Oxygen, nothing, oxygen itself. Oxygen is available in the atmosphere. So then take the oxygen in the atmosphere, combine with the hydrogen. That device produces electricity and water and heat. Three things it produces. Its input is hydrogen and atmospheric oxygen. Combine both this, due to this chemical process, it produces electricity and heat and also water. Output is a water. So that means if you have a fuel cell, the CO2 emission, greenhouse gas is not produced, which is produced by. Please note that if I use hydrogen alone as a pure fuel in engine or in fuel cell, the output is a water only, electricity, heat and water. But in IC engine, main problem is the hydrogen fuel is converted into heat. Heat is converted to mechanical, this one. So once you convert heat to mechanical energy in any combusting engine, then thermodynamic cycle comes into picture. Automatically 40% of thermal efficiency, correct? 100 joules energy is given, only 40 joules can be converted to mechanical energy, correct? Remaining for 60 joules is wasted in any IC engine. The hydrogen fuel or methanol, ethanol or diesel, petrol, coal, water, any IC engine, correct? Coal is not burnt, but we are talking IC engine means we are talking petrol fuel or diesel, LPG, whatever it may be, any hydrocarbon based or hydrogen based. Also, the thermodynamic cycle comes into picture, only 40% is possible. Maximum thermal efficiency. But in fuel cell, if I allow the hydrogen fuel inside the fuel cell, because you can see that this is a fuel cell typical cut section, you are picture, you can say that fuel is nothing but hydrogen. Hydrogen is entering, and other side air is entering. Actually, what I need is O2. O2 I need not separate, because you can pure O2 also can supply. That means producing pure oxygen from the air. Remove is again energy involved process. There's no need. Just like engine, IC engine, suck the air. It has oxygen. That is coming. That will be, once it goes into the fuel cell, as again is at an anode, it has a cathode, it has an electrolyte. Correct? You can see the head plate called electrolyte. Hydrogen is when because there's a membrane. Correct? This is a membrane which allows hydrogen to penetrate through the membrane anode and go and react with the electrolyte, and it produces H plus ions. That is positive ions. Hydrogen convert to positive ions. That means we know that hydrogen has one proton. That proton only we call it the plus one because it's positively charged. The electron is removed. That electron is going away as electricity. It goes to electrical load. Correct? So the electron of the individual the hydrogen atom is removed from the atom and it is circulated to external. That is what you call electrical. That's how it produces electricity. So the hydrogen atom combines with oxygen, correct, O2, then it produces H2. Hydrogen becomes H2O and also releases the electrons, which is the electricity. During this process, it also produces heat. Correct? That heat can be used for something else. Correct? Fuel cell produce heat. That heat can be used for heating something or whatever it may be. Generally, you need to cool the fuel cell. Otherwise, you get overheated. It will burn. It will get destroyed. So that means you have to cool. That could like IC engine. Combustion happens. You use a coolant. Correct. Nowadays, you are trying to recover the engine heat. In the coolant heat also for heating your cabin, all those things. Correct. Like that, you can extract the heat from the fuel cell, and that can be used for heating cabin or whatever maybe. Anyway, you have to cool it. So this is our basic operation. We are going to talk more about fuel cell, different type of fuel cells when we talk about battery, all those things in the later part of the course. So it produces oxidizing acid and the electricity produced. The process called redox. This one similar to a battery, but the fuel is here hydrogen. Fuel cell uses hydrogen as a fuel. As it can be pure hydrogen or natural gas or any other liquid fuel which contain hydrogen atoms. Correct? Any liquid fuel or gaseous fuel or pure hydrogen can be supplied as a fuel, as an input. Of course, oxygen is needed coming from the air. You can suck the air and goes into both will be sent inside the fuel cell, and you get water, heat, and electricity. That's how the fuel cell works. So if in your electric vehicle, hybrid vehicle, you replace the battery using the fuel cell. Okay. Advantage. This is a if you produce. Please note that another thing is you need to produce hydrogen with green energy. Hydrogen production has to be done, and it will be done with the green energy like solar, wind, geothermal, or any other which doesn't burn fossil fuel. Because to produce hydrogen, because any production of any this one needs energy. If energy produced is green means, and that fuel hydrogen used for stored in a tank and is used inside a fuel cell, then we know that we are reducing greenhouse gases. So that's why fuel cell also gaining popularity. Two things. Fuel cell advantage, again, it is using hydrogen only. It's a hydrogen based IC engine. Fuel cell based electric vehicle is much better because here efficiency electric motor 90%. The conversion efficiency of the fuel cell is much better than the IC engine. Okay, so we can see that's what it is. So what is the advantage of fuel cell? There are different type of fuel cell there. One is called proton exchange cell, phosphoric electric acid fuel cell, solid acid fuel, alkaline cell. These are many types. These are 4 different types of fuel cell technology available through which you can produce electricity. They call fuel cell. Correct? We'll talk about this later. What is the advantage of fuel cell? As I told earlier, it produces zero emission. CO2 emission is zero. No CO production, no HC production, no NOx production. Correct? All these things are byproduct of IC engine. Correct? And that is not produced. Then higher efficiency. Hydrogen fuel cells are generally efficiency of 40 to 60%. It can go up to 60%. IC engine, I told you, only 35%. For example, take hydrogen based IC engine, hydrogen fueled IC engine. Right? You are burning hydrogen inside the IC engine. So automatically thermodynamic cycle, as I told you, thermodynamical kicks in. only 40%, maximum 40%, maybe 35%. But here you can go up to 60%. Correct? So that means each percentage is matters. That another thing. Apart from that, zero emission. No, even CO2 is not produced. Not only toxic chemical CO, HC, all this thing, it doesn't produce. It is highly robust and reliable. Hydrogen fuel cell technology has proven itself again tough conditions, including cold environment. You know that batteries will not produce electricity in cold condition. Correct? Battery has to be maintained, some lead acid battery, lithium, and all those things. You need to maintain some temperature. You cannot operate 0 degree less than. But many times in northern hemisphere, like Europe, then Japan, China, Russia, USA, Canada, correct? 3 to 4 months, very cold condition. There, so your battery will not work. Correct? You need special heating, all those things. Otherwise, battery will not produce electricity. But hydrogen fuel cell still works. It can work even lesser up to minus 40 degrees centigrade. Correct? It can work. Minus so fuel cell can produce electricity. The battery will not produce. So that means instead of battery, lithium and lead acid battery, if I use fuel cell produce electricity for my hybrid vehicle or electric vehicle, it is better, highly reliable in cold condition also. And it is easily scalable. Correct? So if you increase the size of the fuel cell, volume of the hydrogen going in the sun, I can produce whatever the more voltage, more current, bigger. That is scalable bits, make it bigger. Correct? Is possible. And lower operational cost compared to battery, maintenance of battery, all those things compared to fuel cell has a lower operational cost. These are few reasons why people are trying to go to fuel cell compared to battery based driving electric vehicle. Again, this also there is a lot of, see, please note that I give 4 or 5 positive side. In the universe, nothing is good, nothing is bad. Correct? When we say that we good, we'll say that I take some 10 points. Out of that, 6 or 7 points are good, 3 or 4 points are then I say that person is a good person. If the person has a 8 good quality, 2 bad, I say he is very good. Correct? And no person will be completely bad. He doesn't do any good thing at all. 0 good things, all 10 are bad. Similarly, all 10 are good, no bad thing. You will not find anybody in the universe, or at least in the world. Correct? Bad and good, the mix up. But we say that if more goods are done, we say that grading. Good, very good, excellent, something like. Even excellent fellows still make 1 or 2 mistakes. Maybe he may make 8 or 9 good things, 1 or 2 mistakes he will make. Similar to that, any technology, whether battery, fuel cell, IC engine, all those things as good things, it also has limitation. Those limitations we'll see in the when we talk about fuel cell battery later. Okay. Now that we talked about why we have to go for hybrid electric vehicle, reason, all this thing we explained last 5 to 6 classes, internal architecture, layout, many things, technical also we talk, not only introduction, we talk many technical layouts, all these things. Because why I'm saying is, in the exam, you can expect questions, what we have talked till now, right? So midsum exam is coming in the middle of March. That time you need, that's why I'm just talking. Please take notes, very important. I cannot share the PPTs. Okay, that is well known to all of you. Maybe 2024. Yeah, you already know that we did an introduction autonomous vehicle. So please take notes. Okay. Now that I wanted to start dive deep into the modeling, all those things, electric vehicle, the hybrid vehicle, all those things, how to find what should be the power, how much power is wasted, all these things we are going to talk, transmission, all these things one by one. First thing is to talk about that many times we use modeling and simulation nowadays. That is become very popular. We saw in the mechatronic course, correct? Modeling simulation became very popular because without making the physical prototype, which takes lot of money, lot of time, lot of efforts, something goes wrong during the initial prototype testing, correct? For example, nuclear reactor, correct? If something goes, you are designing new reactor. If you don't control properly, it can accident can happen. It can this one. Then it will emit radio emission, correct? Too dangerous for nearby city, hundreds, at least thousands of years. So they say that the nuclear reactor design, all this thing will be done through simulation. Now it is possible. Some 20 years before, you did not have the computer, you did not have software packages. Now many are 7 bigger aircrafts, correct? new aircraft, bigger machines, correct? Making physical model may take near. As I told in the mechatronics, for example, A380 Airbus or Boeing, correct? Boeing 777, 787, correct? All these things. Nowadays, for last 20 years, the new design will be done through what you call modeling simulation, which we call the mechatronic way of design. Electric model, each and every component will be modeled using a mathematical equation, and you run the program, what you call a simulation, vary the parameter, optimize design. When everything is okay, then make the physical model, prototype, physical prototype. By the time the product would have matured. Matured means design wise you would have matured, correct? So modeling simulation plays very vital nowadays, right? Money, time, energy, and like accident, all these things can be avoided in initial stages. So because of that, we are talking about modeling. We are going to talk about that. Layout of IC engine based vehicle. Already we know, nothing new. We have talked in many times. Basically, you have an engine, correct? Then you have a flywheel, correct? We know that here it is producing pulsating force, correct? Piston is engine, we are talking IC engine, reciprocating engine. So the only doing power stroke, the torque is produced, it is a pulsing, correct? The torque is a pulsing like this. In between, there's no. This is only doing power stroke. Remaining stroke. So that if a direct connect to wheel, your vehicle will jump, jerky movement will be there. It's smooth movement over there. So we are adding a flywheel. Already you know that flywheel acts as a low pass filter. Flywheel acts as a low pass filter, the mechanical filter. Mechatronic, I talked about it. When we talk about electrical filter, I told this still I remember. So what happens? It smoothens the output. This is what coming input to the flywheel. Flywheel will provide something like this. You can see the almost smoothened. This is what is going to gearbox. From gearbox, it go to wheel. So vehicle moves smoothly. That is the advantage of flywheel. Okay. From flywheel, it next goes to clutch, which can connect the engine to the gearbox and finally to wheels, or you can disengage. So the power can be, or torque produced by engine will be disconnected, so that vehicle can be stopped whenever apply this. So then, of course, you have the gearbox. Okay, you have the gearbox. Then you have a differential. Please know the differential also another gearbox. I can say GB2. This is GB1. Okay, gearbox on this one. And finally, it is given to wheel, driving wheel. So IC engine generates power, basically literally generate torque. And if the torque is sufficient to overcome all the loads, okay, then the remaining torque will be given to the wheel, and then wheel start rotating, vehicle start moving, correct? Vehicle will be driven, provided torque generated is sufficient to overcome the loads acting on the vehicle. Okay, what are the loads? Note down, please take the important point, because exam, I'm again repeating, exam, you need to take the points. Not only saying, but whatever I explain, also you have to write. Okay, the various loads involved in any vehicle. We are talking IC engine, it is applicable to a hybrid vehicle and also electric vehicle. So internal frictional loads. Please note that wherever two moving parts are there, there's a friction. Piston is moving inside the cylinder, there's a friction, correct? Then connecting rod is there, and crankshaft is there. Crankshaft is supported by bearing, there's a friction, correct? Then like that, wherever mechanical movement, gearbox, inside the gearbox, there are gears as touching, mechanical contact, they are moving with it relative to each other. Wherever there's a relative motion, there's a physical contact between solid to solid, solid to liquid, or solid to gas, correct? Anywhere, this one, relative density, that there are two parts are moving, there's a friction, right? So the friction is generated. Internal friction generated engine, gearbox, and transmission system, okay, including differential, correct? Then road resistance, because wheel is touching on this one, there's a friction, wheel friction. Okay. Then load due to uphill. When vehicle is moving in the plain road, there is some amount of this one, which is called the inertial load, because you have the vehicle has a four wheels, other side this one, they are touching. The vehicle has a mass, for example, 1000 kg, correct? And 1000 kg is divided into four parts, 1000 divided by 4. That means 250 kg mass is acting on each wheel, four wheels. So 250 kg multiplied by 9.8. Gravitation action is the normal force acting on each wheel. This is called inertial load. This load also opposes the motion of the vehicle. Correct? Then road resistance friction, that is between wheel and the road surface. Then internal friction. Then when vehicles start moving, the wind is blowing, correct? Because the wind comes and hits the this one. So the wind generates the friction, wind resistance, which is also called aerodynamic load. And other environmental factor, like when vehicle is turning, lateral forces are acting, correct? When the vehicle turns a sharp curve and all those things, then wind, sideway wind, not only frontal wind, correct? Sideway also wind can be windy season, correct? Maybe next wind, we say 3 to 4 more windy season throughout the country will be there. When you go sideway also, there'll be wind. And because of there's a lateral forces acting, road surface condition varying, ice, correct? Or water, all those things, surface condition, snow, anything, that also generates additional. These are the important loads acting on the vehicle. Okay. Now, when we talk about engines, we are going to design a vehicle, and vehicle has to take some amount of load, correct? Vehicle own mass plus passengers from additional goods. If you take a passenger vehicle, for example, I say 1,000 kg vehicle or this one, then you are adding fuel, maybe 30 to 40 liter fuel, correct? And depending on density, the weight will be added. Then four or five passengers is luggage, all those things. So I say the 1,400 kg in a typical vehicle, 4% 75 kg into the 4, correct? Sometimes we will overload also. The vehicle has to take, already, abusing the vehicle is very common in many countries. Okay, so this is around 300 kg, vehicle 1,000 kg, then fuel around 30 to 40 kgs, and luggage another, I say that another 100 kg. If you add around 1,400, 1,500 kg will be loaded. That much load is going to act on this one. We are talking about, that is the mass of the vehicle. Mass of the vehicle, due to which there is a inertial load acting on the 4 wheels multiplied by gravitation, that is going to happen. Okay. Now, when we talk about vehicle, I told you the vehicle engine, who is going to drive? A engine. Engine has to produce the torque, and this torque is the producer torque from the engine. I said TE, engine torque, right? Which is trying to do. So we know that as the engine vehicle speed means the throttle automatically, that means the engine speed is vary from 0 to 10% throttle, correct? 0 to 10% throttle. If I vary, my vehicle speed varies from 0 to 100 kilometer kmph, right? So this is what throttle I varying. So you can see that engine torque increases as engine speed varies, and the torque also, we know engine torque is not constant, already we know that. Similarly, the load torque, correct? Load torque, already we talked about various torque, correct? These torques are not constant. For example, if you talk of wind resistance, aerodynamic drag, that will be 0 when vehicle speed is 0, aerodynamic drag is 0. Okay, when vehicle speed is 0, this one now 0 kmph, then no aerodynamic drag. But the static friction works. Engine friction works because engine is still running. Idle condition or first gear, vehicle has not moved, but this one. And the vehicle is going in a plain road, this torque is 0. Correct? Uphill, downhill, gradient, due to gradient, there's a load created. That becomes 0. Or uphill means will be added, downhill will be reduced. Both are not there. And like this, so these torques are loads are not constant. They vary depending upon the environment, situation, and speed that vehicle is moving. Correct? It is not a constant. So that means the load torque also is varying depending upon vehicle speed. Correct? And road condition, vehicle speed, all those things, you will see that it also increases and this one decreases. Okay. Now you will see that at particular speed of the vehicle, both engine torque and the torque required. That means this is the torque required to overcome, then only vehicle will move. Engine produces a torque. This is a torque required. This second curve is this one, and they meet on particular condition. This is called optimal or operating point, best point to run your vehicle. Correct? But this condition is not always going to be there because your vehicle itself is varying different speed. So different region it is operating, right? So the best one will be where the both meet, the curves are meeting. That's what I want to say. Operating by a vehicle is the combination engine and load system curves. These curves are this one where they intersect. That is best point, but that point is it's not this one. So vehicle is
Sir,
yes, please.
so just one doubt on the graph alone.
Mm.
This engine torque first curve has been plotted for separately for the engine, and then the load
Not for
torque curve is
no. Engine
okay.
torque, which is driving the yeah. This is a driving torque. Yes, you are correct.
Okay,
Engine
sir.
is connected to V because we are
Okay.
talking about vehicle speed. This is vehicle speed. Automatically,
So,
engine
sir,
speed also ring.
so the load torque curve is basically when the vehicle is being pulled, right?
Yeah, it is pulled.
So at some point, the load torque curve should be higher than the engine, right? Because reduction gearbox and all is there. So
Low torque.
load torque curve will go beyond the engine torque, right? Or it should not be that way.
We are talking about first gear, second gear, all this thing. Right?
Yes, sir. Exactly.
Yeah, it will vary, but we want to operate here. But generally, we will not be able to get. This is only one point it meets. Other points is not. Okay, so it doesn't meet, but this is the best operating point. But since vehicle speed itself varying, you will not always operate here. At this point, you will get the best output from the vehicle driving the load. That's what we are trying to say.
Okay, sir. Okay.
Okay. Then apart from this, load includes this one, frictional road, all those things. What are the other additional loads in a vehicle? Correct. We have other additional loads like brakes. Correct. Then the loads acting on vehicle can classify as mechanical and electrical. There are two categories. Correct. For example, if you talk about braking, brake shoes also opposes the forward motion. Correct. That is a mechanical load. Then HVAC system, air conditioner. Air conditioner can be belt driven. Correct. The air conditioner compressors can be belt driven, then it is mechanical, or it can be a modern vehicle. Nowadays, you will see that you have electric motor driving the HVAC air conditioner. Directly, it is not connected to engine through belt. Okay, so it can be a mechanical or electrical load, and that means what we say, all these loads, correct, should be added, and engine should produce torque more than all this load, then only vehicle will move. That's what we want to do. Then cooling system, correct? Cooling system also yes, a radiator fan, correct? It can be belt driven or electric motor. Whatever it is, who is supplying the energy? Please note that any load, the energy is supplied from engine or electric motor or combined. If it is a pure IC, engine load. If it is electric, motor load. If it is a hybrid vehicle, combinedly they are producing the torque so that it can overtake all this load. The engine torque should be greater than the combined torque or load torques. So then various pump, correct? Pumps also taking energy, correct? It is electrical. When you say pump, correct? It can be built in old. I'm talking very old generation, correct? Maybe the fuel pump may be driven by belt itself, but of course nowadays is electric motor. Okay, fuel pumps also it needs energy. Then window motors, correct? Window glass up and down. While you're driving the vehicle, you will be moving the windows up and down. The electric motor takes energy. From where it is coming? It is coming from engine only. Correct? You say it is coming from battery. Who is charging battery? Finally, engine. Correct? Energy is coming from this one or from the pure plug-in hybrid from wall mount. Again, you are charging battery. Then window locks. Please see the window locks. Once in a while, there is an electric motor or solenoid. They are also taking small, but each one have 1 watt, 2 watt, 5 watt. If that will become 1 kilowatt. Then wiper motor, headlamps, correct? Horns, correct? Tail lamp, cabin lamp, horns, correct? Then entertainment system, correct? GPS system, any electrical system this inside vehicle. Then other subsystem like engine management system, fuel injection system, ECU takes care of electrical, ABS system, ECU, correct? EPS, electric power steering, hydraulic power steering, assisted steering, traction control, any other please see that any electronics like ECU, sensors, hybrid, whichever take electrical power, and that is also called as non-propulsion loads. This one is called as propulsion loads, correct? When engine moves only, friction happens. then only vehicle propelling. When wheel is rotating, then only road friction comes. Again, propulsion. This will wind resistant. All these things are called as propulsion loads, correct? And plus this plus non-propulsion loads. All these things, vehicle body, all these things are called non-propulsion. Note down these points. Together, they are called propulsion load plus non-propulsion load. Correct? Together, they form the load, and the engine torque. I say the torque by engine torque. I say TE should be greater than the load torque. I say that torque L, TL, which include propulsion loads and non-propulsion listed here. Correct? This is applicable to whether pure IC vehicle or a electric vehicle or a hybrid vehicle. Okay. Then we also talk, whenever we talk about vehicle testing, all this, we are talking hybrid electric vehicle. What do you talk about? Drive cycles, right? So there are many drive cycles. A typical drive cycle called EPA drive cycle, which is used in US, correct? We have Indian drive cycle, European drive cycle, Japanese drive cycle. Each country has one. This is called EPA drive cycle used in US. All American company, they will be testing their vehicle against this drive cycle. A typical drive cycle is called EPA Urban Dynamometer Driving Cycle, UDDS, correct? So generally, the x-axis it talks about time in seconds, y-axis talks about vehicle. That means we are testing the vehicle as if this drive cycle is trying to simulate the actual road condition. You drive your vehicle not at constant speed, correct? You will accelerate, you decelerate, apply brake. That means basically by applying brake, you are reducing to decelerate. You run your vehicle at different speed for different amount of time. For example, you can say that at time t equals 0, from this one vehicle is not moving. And from the, for example, this may be 10 seconds. At 10 seconds, you are accelerating. You can see the vehicle speed from 0 RPM, it goes to 20. Here they talk miles per hour because of the American this one. So suddenly you are accelerating. Put the first gear, and if, for example, you are operating, correct? Sharply, it goes up to 20 miles per hour. Then it is moving, correct? Then it is oscillating like this. Then it increases and goes to a peak of 30 miles. Then suddenly comes to 0 in very short duration. So you can see that with respect to time, vehicle speed is varied and maintain a different speed, correct? And need not be constant. And again, it becomes 0. So after for some amount of duration, then again you are increasing. Please note that then again it goes up to 6 like this. You are operating, correct? So test time, they say that EPA drive cycle means they say 1400 seconds you have to drive your vehicle, correct? And where is the vehicle speed? While doing this, you will find out fuel consumption, correct? You will emission, how much emission is tailpipe emission is produced, correct? Emission produced. Any other performance, vehicle performance data, you will measure. How will you do that? That means you need to vary the vehicle speed like this, correct? Like this for different duration maintained. That will be done using in the lab condition. We'll see that. What is a vehicle drive cycle? A few way.
Sir, one question I want to ask, if you allow, sir, please.
Definitely, please.
So basically, one thing is that we have a claimed mileage of the vehicle.
Okay.
For any manufacturer, they give the vehicle, like what I mean to say is, and typically when it is published, it is star marked that the vehicle is driven in a standard condition. And we all know that if we drive the vehicle for a particular speed or a steady state like condition, the mileage of the vehicle is much higher than a transient driving cycle. What I mean to say, when we accelerate or decelerate the vehicle very frequently, it will give a very low efficiency compared to a vehicle which is driven at constant speed. Right, sir?
Correct. Optimal speed. If you drive at but the drive cycle, what they say is, for example, tomorrow you are going to start in your car company, you are going to produce. You want to tell me you have to go and get certification from Pune. What is that test center? No, government test center. Yeah, correct. Yeah, I will say Indian drive cycle, your vehicle will be put on chassis dynamometer And chassis dynamic companies will be doing, correct? You will drive the vehicle, you accelerate, a driver will be sitting inside the vehicle, and the way you start the engine, put the first gear, second gear, you have to follow this. You see the speedometer in front of you, big panel bit, definitely you would have seen your company, and the test driver who is driving the vehicle, and he chassis driver, not on the test track. Chassis dynamometer, you will try to see the vehicle speedometer is following this, exactly like this. During that, then they measure the fuel efficiency, how much fuel is consumption, emission, all those things, and that should meet an Indian drive cycle. Then only your vehicle will be allowed to sell, or you can claim, correct? But that means what we are trying to say, that's what I'm trying here. You cannot, because vehicle is not going to driven at constant speed, correct?
No,
Actual
sir,
vehicle.
my question is a little different, sir. What I mean to say is like there is a deterioration in the fuel mileage when we are driving the vehicle in the transient condition, where the vehicle is being accelerated or decelerated in that.
Yes, definitely.
Now,
Yes.
yes, sir. So let's say that the percentage of deterioration is for a given cycle condition is about X%. Now, if I drive the same, like I would say, similar condition of EV,
Okay.
then whether in the transient condition, EV's deterioration will be sharper than compared to ICE, or it will be
Yeah,
similar?
you know, dynamic response electric motor, no. Dynamic response electric motor is always better because at 0 speed it gives full torque. Correct. So, for example, in the drive condition, what you did, you brought the vehicle motor to 0 speed. Suddenly you are trying to accelerate. The electric motor can suddenly accelerate. Correct. It can give maximum torque at 0 speed. So definitely electric motor will give better performance.
But what will happen to battery state of charge, sir, actually?
That is what is the please note that the battery should be able to supply the energy demanded by motor. That means you have to have a right battery. That is why it comes in picture. Lithium-ion battery. What do you call as? What is the rate at which it can discharge rate? Correct. The battery should have a capacity to discharge. For example, sudden acceleration, it needs 200 amps or 400 amps. Correct. Current, peak current. Suddenly you have to accelerate. Correct. So the battery should be able to give. If it is not giving, motor won't accelerate. So that's why the criticalities come to battery also. Whether battery can discharge this much current in few milliseconds. That also matters.
Okay, sir. Thank you, sir.
So that means what you do is you will buy a bigger battery. If you see main problem, what will happen? Good thing you asked. Correct. I have a battery 600 volts and it can give, say for example, 500 amps current. Correct. Maximum peak current. But this is peak current. Whether it can discharge in short duration. They call discharge rate. Discharge rate of battery is very important. It should be able to immediately within from 0 second to within 0.5 second, that is within 500 millisecond, the current should be able to produce this much current. Right. So battery also matters.
Right,
Okay.
sir. Right, sir.
Okay.
Basically, right, sir. Thank you.
Okay. Yeah, very limited because we know that vehicle actual driving condition, actual vehicle driving is different. You never able to simulate in the laboratory to check whether vehicle is performing to what I talk, whether mileage is giving, emission, all these things. So what they did, they devise a mechanical drive cycle. A limiter switch in a vehicle moving on the road at a different speed and time duration is called as a drive cycle. What is a drive cycle? That's what I told you. It is moving at a particular for some duration at a different speed. Correct. You can see that y-axis this one. Vehicle is driven like this, and then they called as more or less typical road profile or terrain. Correct. The vehicle is accelerated or decelerated, then upslope, downslope, plain road, all those conditions are taken care by drive cycle. And so this is to simulate the actual vehicle moving in the actual road. But I want to test it because I am making a new vehicle. I want to test it. But driving the actual road is difficult. First thing I want to test in the laboratory itself. So how do you do? I use a chassis dynamometer. In the chassis dynamometer, for that, I will create a particular profile that is called as drive cycle. Using few of this profile, one can create some new arbitrary profiles also. Correct. So you can see here UDSS is there, urban dynamic driving cycle. Like that, other driving cycles can be created from one cycle to another, but you have to drive the vehicle in actual condition and get the data. Correct? Speed you drive at this all this time. From that you can synthesize and create the drive cycles. But that is done by the ARI or the EPA. They create all these things and they give the drive cycle that can be used for this one. Driving a highway, correct? Inside the city where you apply frequent braking, frequent acceleration, complete stop in signal, and downhill, all these things. Drive cycle are used to compare the performance of newly developed vehicle in laboratory conditions, generally tested using chassis dynamometer. Correct? Chassis dynamometer in terms of fuel. What for? Find out whether your new vehicle is providing this fuel economy, what you are expected, and the emissions are reduced as per drive cycle when you do that. Drive cycle concerns rapid road profile through which vehicle goes through. Hence, the situation is external to vehicle. Please know that drive cycle only trying to simulate. This is what in India happened. Indian drive cycle, Indian city, you did in Indian highways, Indian state highways, if you drive my vehicle, and this is how you will apply a brake, you will accelerate, all those things you will do. That's what you're talking. Okay. That's what we are going to talk. Then performance and response of vehicle in given drive cycle in terms of fuel economy will be different depending upon whether vehicle is IC engine based or a electric vehicle or a hybrid vehicle. Just now, Rawson is as similar. That's what it is. It is for same drive cycle, different vehicle will different. This one, because we know that electric motor always gives the higher efficiency. And its conversion is better than IC engine. So that means automatically mileage more, all the electric will be better than HCV, correct? And it will be better. HCV is better than the pure IC engine base. But all this thing can be tested and you can prove. Okay, I stop here. And the next class we'll talk about, as I told, deeper into modeling the hybrid electric vehicle, how to calculate electric motor power, how to this one, like that. Slowly we start doing. Please give your attendance as a chat message without forgetting. Have a nice weekend. We'll see you on Monday evening, 6 o'clock. Any questions I can answer.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay. Take care.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
I am going to close. Please give a chat message before leaving.